In the question, they give us a function and then they describe the function like when it is divided by something, then the quotient and remainder are the following respectively. So to try to build up the original function by the given divisor, given quotient, and also given remainder, we are going to break down the sum number first. For example, like 13 divided by 4. So we get 3 and 12, and then the remainder is 1. We call the result quotient. We call the number we divide is called divisor. And then finally, we call the remaining part that we can't divide is called the remainder. When we want to build up 13, it's come from 12 plus 1. That means it is 4 times 3, the divisible part, together with the remaining part. The divisor times the quotient and then plus the remainder. So we are going to build up this item again by using this information. Now, the divisor, they say that it is x minus k. And then the quotient, they say it is a little bit long, 6x squared plus 5x plus 9. And the remainder is 20. We are going to build up the original function, fx. Therefore, by using the information, fx is equal to the divisor, x minus k, times the quotient, 6x squared plus 5x plus 9, and then plus remainder independently. The divisible part and the non-divisible part. You may expand it first, and then you use the information here. Or if you use the information here, you can also get k here as you like. So now I'm not going to expand it. I try to find the value of k first. You have to translate and write down the implication of this statement. Given that when fx is divided by x minus 1, then the remainder is equal to 0. Because divisible, that means there is no remainder. And how we know what is the remainder is by the remainder theorem. They tell you that the remainder is equal to original function. Put suitable values. The suitable values is make the divisor in this case become 0. So the suitable value of x is 1 in this case. f1 will give you 0 directly. So it gives us some equation and relation for us to log the value of k. We just replace every x here by 1. Therefore, we have 1 minus k. We have 6 times 1 squared plus 5 times 1 plus 9. And then plus 20 will equal to 0. In this equation, there is only k as the only unknown. So I can solve it carefully and get the answer. 1 minus k, and then this bracket 6 plus 5 plus 9, we get 20, is equal to negative 20. I want k, I don't want 20, so I divide both sides by 20. 1 minus k is equal to negative 20 divided by 20. It's negative 1, so negative k itself is negative 1 minus 1. And finally, k alone is equal to 2. It is positive 2. We already finished part A. Now we are going to work on part B. Someone claimed that the roots of this equation. So you are going to investigate this equation and the result. Are they all rational number? A student always get lost because they forget that they have to start from the question. This is the requirement. We are going to solve fx equal to 0, this situation. Fx, do we know what is this? We already know that. It's x minus 2 and then times this item plus 20. Equal to 0. If we expand it, we predicted that this is a cubic polynomial. That means x power up to 3. For any polynomial, the power is higher than 2. we have one single solution, which is factorization. So we have to expand it. Because I can't accept the first term and the second term, I just accept one single term, something times something. So I need to expand it now. X times 6x squared plus 5x plus 9. Negative 2 also times 6x squared plus 5x plus 9, where we remove the bracket. So 6x power 3 plus 5x power 2 plus 9x minus 12x squared minus 10x minus 18 plus 20. Simplify the like terms. We have 6x power 3 minus 7x squared minus x plus 2 equal to 0. We have to try our best to write down something times something. This is a process of factorization. It's difficult to solve without any hints, but they tell us one of the factor is x minus 1 is give us some hints. If we use some number example, for example, if I tell you that 12, and then I tell you that one of the factor is 3, I'm asking what is the another factor. So you use 12 divided by 3, and then you get 4. So we know another factor is 4. Now we are going to guess what is the rest of the factor. So we are going to perform division. In our graph, original function 6x power 3 minus 7x squared minus x plus 2, we divide by x minus 1. So we look at the first item, 6x power 3 divided by x, we get 6x power 2. The next step, 6x squared times this item, we have to write down here. So we have 6x power 3, 6x squared times negative 1, negative 6x squared. Afterward, we have to subtract it. Negative 7x squared minus negative 6x squared. It gives us negative 7x squared plus 6x squared. We get negative 1x squared. We finish one cycle, then we just repeat the same cycle. Focus on the first one, divide by x, we get negative 1x here. So negative x squared, and also negative x times negative 1, we get positive 1. Afterward, negative 1 minus positive 1 is give negative 2. So negative 2x divided by x, we get negative 2 here. So negative 2x, positive 2. There should be no remainder because we predicted that x minus 1 is a factor. So this is what the next 6x squared minus x minus 2. Why we have to factorize it is because if we can factorize like this, something times something equal to 0, we can use the zero product rules. In order to get zero product, that means either this factor or the next factor equal to 0, otherwise it's impossible. X minus 1 equals 0 or 6x squared minus x minus 2 equal to 0. We find that from the cubic polynomial is downgraded to quadratic equations. That means it's easier for us to handle. You may factorize it or you may use your calculator. If I factorize it, this is 3x have to times positive 1 and also 2x have to times negative 2. So therefore 3x minus 2 equal to 0 are zero product rules again, or 2x plus 1 should equal to 0. X equal to 2 over 3 or x equal to negative 1 over 2. No matter 1, 2 over 3 or negative 1 over 2 are all rational numbers. So our conclusion is we agree the statement.